Imagine that the universe is not a collection of separate things, not a set of isolated objects, not a stage where particles exist independently of one another. Imagine that everything that exists is deeply connected, not symbolically, not as a metaphor, but physically. We have reached a point where this idea is no longer philosophy. It is measurement. It is experiment. It is result. Reality is not local, and quantum physics has proven it. For a long time, we believed that things existed only where they were, that causes acted only where forces could reach, that information could never travel faster than light. But deep inside matter, where particles no longer have definite positions, a different story begins. A story without distance. When two particles become quantum entangled, separation loses its meaning. Two photons can be billions of kilometers apart and still behave as a single system. Not because they communicate, not because information travels between them, but because they were never truly separate. This is not a hypothesis. It has been measured, again and again, with ever-increasing precision, under conditions that leave no room for classical explanations. Once, this was called spooky action at a distance. Even Albert Einstein was unsettled, not because the experiments were wrong, but because their implications were too deep. Because if reality is not local, then space is not what we think it is. Then separation is not fundamental. Then closeness is not measured in meters. Then the universe is something deeper. Close your eyes for a moment. Imagine two particles born at the same time. Not as points, but as possibilities. They move apart. Time passes. Entire galaxies could form between them. And still, when we measure one, the other responds. Instantly. Not with a signal. Not with energy. Not with delay. The response is simply there. This does not mean that information travels faster than light. It means something more radical. Information was never tied to a location. Reality is not distributed across points. It is shared. This knowledge does not only change physics, it changes our picture of the world. Because quantum entanglement is not a marginal phenomenon. It is not confined to laboratories. It is not a trick of isolated particles. It is fundamental. Experiments with ever larger systems show that entanglement does not vanish as systems grow. It persists. It scales. It survives. Molecules, crystals, macroscopic systems. The boundary between the quantum world and the classical world begins to blur, and with it, the boundary between here and there. What does this mean for space, for time, for consciousness? If reality is not local, then properties do not exist independently. Reality arises only in interaction. The universe is not a clock, but a network of relations. It is not particles that are fundamental, but correlations. Not things, but connections. This is difficult to accept, because our brains evolved for objects, for boundaries, for causes and effects separated by distance. But nature is not obligated to follow our intuition. It follows its own rules. And those rules tell us, the world is far more deeply connected than we ever imagined. We will move slowly into this new understanding, without rush, without overload, step by step, deeper into a reality where separation is not fundamental. Breathe slowly. Let go of the idea of distance, because perhaps you were never truly separate from the rest of the universe. Perhaps it is worth stepping back and remembering how confident we once were. How deeply rooted the idea was that the world is made of separate things. Particles here, forces there, effects only where causes can physically reach. This worldview was not naive. It was effective. It carried physics for centuries. It allowed us to calculate orbits, build bridges, design machines. It shaped the way we think about reality in everyday life. But beneath this stable surface, there was always a quiet tension. Because at the beginning of the 20th century, matter began to behave strangely. Electrons stopped being tiny solid spheres and became probabilities. Light was no longer just a wave or just a particle, but somehow both. And measurements seemed to influence outcomes. For a while, all of this could be organized. We spoke of uncertainty, of statistical effects, of limits to our knowledge, until a question appeared that could no longer be avoided. What if the world is not made of separate objects? What if properties do not exist locally? What if particles have no individual identity until the moment they are measured? From this question emerged one of the deepest problems in modern physics. Imagine two particles born together, not one after the other, not independently, but as a single quantum system. At that moment, they do not possess fixed properties. No spin, no polarization, no direction. Only when a measurement is made does a result appear, and that result applies to both. Not as communication, not as a signal, but as a shared state. When one particle is measured, the state of the other becomes defined, regardless of distance, regardless of time, regardless of everything classical physics would normally require. This idea was so unsettling that even the founders of quantum mechanics resisted it. Albert Einstein believed the world must be incomplete. He was convinced that hidden variables had to exist, local properties we had not yet discovered, a deeper layer of reality that would preserve order. Not because the experiments were flawed, but because their consequences were too radical. Because if no local hidden properties exist, then this means something unavoidable. Reality is not local. A particle does not carry its properties by itself. They arise only in relation, in correlation, in connection. This is where physics began to touch philosophy, not out of weakness, but out of depth. For a long time, this question remained open. We could calculate, make predictions, build technology, but we could not decide whether reality was truly non-local or whether essential information was still missing, until experiments became possible that could test this question not theoretically, but physically. Pairs of entangled particles were created. First photons, then electrons, later atoms. They were separated, sent in opposite directions, measured independently. If the world were local, the results would obey certain limits, limits that can be written mathematically. But nature crossed those limits, every time. Not in a single experiment, not in one laboratory, not on one continent. For decades, with increasing precision, under conditions designed to close every loophole. The correlations were stronger than any local theory could allow. Not slightly, not by chance, but systematically. Reality behaved as if the particles had never separated. And here, the real astonishment begins. Because these experiments do not say that information travels faster than light, they say something deeper. They say that properties do not exist locally, that the world is not built from things exchanging signals, but from relationships that manifest. Space does not separate systems. It only organizes appearances. What we measure is not what is. It is what appears when we ask a question. And the deeper one reflects on this, the clearer it becomes. Particles are not the fundamental building blocks of reality. Neither are fields nor energy. Correlations are connections that exist independently of distance. This is not poetic language. It is the most restrained interpretation of the data. The world is not a mosaic of isolated pieces. It is a coherent whole that appears locally, but exists globally. This idea may feel strange, unsettling, difficult to hold, but it explains why quantum computers are possible, why quantum teleportation works, why entangled systems contain more information than their parts should allow. It explains why separation is not a foundation, but an appearance. And as we begin to understand this, something essential shifts, not only in physics, but in how we understand ourselves. Because if the world is not local, then neither are we, entirely. Then observing is participating. Measuring is interacting. Knowing is relating. We are not outside reality. We are embedded within it. And perhaps this is the moment where modern physics becomes quiet and deep. Not because it knows less, but because it has recognized that connection is more fundamental than separation. Breathe slowly. Let this idea rest. The world is not out there. And you are not only in here, both are part of the same whole. As this understanding settles, something begins to shift quietly. Not abruptly, not dramatically, but steadily. Because the consequences of non-locality do not end with experiments. They extend much further. They reach into the question of what space actually is. In classical physics, space is a stage, a container, something that separates and orders. One object here, another there, distance in between. But quantum experiments tell a different story, one in which space does not truly separate, but merely labels. If two entangled particles remain correlated across vast distances, then space cannot be a fundamental divider. It is not the cause of independence. It is simply how appearances are arranged. This means space is secondary, not the foundation, but the surface. Correlation lies deeper. One could say that space describes where something appears, not what it is. And the closer one looks, the clearer it becomes that this idea is not entirely new. It was simply hidden for a long time. Quantum field theory already suggests that particles are not isolated objects, but excitations of a shared field. Not separate, but locally visible. Non-locality goes one step further. It suggests that even these fields are not independent. They too are entangled. What we call separate systems may be projections of a deeper relationship. This may sound abstract, but it has measurable consequences. In modern experiments, entangled states are maintained across ever greater distances. Not seconds, not minutes, but scales that challenge classical intuition. Photons are exchanged between satellites, between Earth and orbit, across continents, and their correlations remain, not despite the distance, but independent of it. This forces physics to reconsider its most basic assumptions. If space does not fundamentally separate, then time may not be what we usually think either. Time is closely tied to causality, to order, to cause and effect. But in entangled systems, there is no clearly defined before and after. There is no privileged temporal sequence. There is a global state that becomes definite when measured. The event is not localized, it is distributed, not in space, not in time, but in relation. For this reason, some physicists speak of a reality in which space and time are emergent, not given, but arising. Like temperature, which emerges from collective motion. Like pressure, which belongs to no single atom. Space and time may be properties of collective order, not fundamental building blocks. And non-locality becomes a window into this deeper level. This perspective helps explain why unifying quantum mechanics and relativity has proven so difficult. Relativity treats space-time as fundamental. Quantum physics quietly undermines that foundation. not out of contradiction, but because it reaches deeper. Perhaps space-time is only an approximation, a macroscopic picture, a perspective that works as long as we do not look too closely. But once we descend to the level of correlations, that perspective begins to fail. And here, something decisive happens. If space and time are not fundamental, then separation is not fundamental either. Isolation is not primary. Connection is. This does not apply only to particles. It applies to systems, to processes, perhaps even to observers. In quantum mechanics, the observer is not passive, not outside, but part of the interaction. The measuring device, the experimental setup, the choice of what to measure, all influence what appears. Not subjectively, not psychologically, but physically. Reality responds to questions, not arbitrarily, but consistently. This means reality is not a finished object. It is a process, and this process is relational. What exists does not exist by itself, but in relation to something else. This changes how we think about information. Information is not a thing that travels. It is a structure that is shared, not sent, not received, but jointly realized. That is why quantum entanglement does not violate the speed of light. There is no transfer, no transmission. There is only a shared order that appears in two places, or rather, two appearances of the same state. The longer one reflects on this, the less useful the word place becomes, and the more central the word relation. The world is not made of points, but of connections, and perhaps that is why non-locality felt like a paradox for so long. Not because it is contradictory, but because it outpaces our intuition. Our minds are local, our experience is local, but reality is not. And here, a new kind of humility emerges. Not religious, not metaphysical, scientific. The recognition that our intuitive categories are not final. That space, time, object, cause, observer are tools, not ultimate truths. Tools that work remarkably well as long as we do not absolutize them. Quantum physics does not tell us that everything is arbitrary. It tells us that everything is connected, and connection is precise, mathematical, measurable. Perhaps that is its greatest demand. Not that we abandon causality, but that we abandon the illusion of isolation. Breathe calmly. Let the idea of space as a boundary soften. Perhaps closeness is not measured in distance, but in relation. And perhaps here begins a deeper understanding of what it means to be in this world. If one follows this line of thought further, an inevitable question appears. Not because it is mystical, but because it is unavoidable. What does non-locality imply for what we call consciousness? Not in a spiritual sense, not as metaphor, but as a physical question. Consciousness is not an object in space. It has no clear position, no volume, no extension, and yet it is real. We experience it. We are it. In a strictly local world, consciousness would have to reside somewhere, in a point, in a bounded region. But quantum physics quietly undermines this picture. If properties do not exist locally, if states arise only in relation, then it becomes at least conceivable that consciousness is not an isolated thing, but a process emerging from relationships. This does not mean that consciousness controls quantum events, and it does not mean that thoughts influence particles. Those shortcuts do not help. They blur what is actually precise. But it does mean that the strict boundary between inside and outside is no longer self-evident. The brain is a physical system. It is made of matter subject to the same laws as everything else. If those laws allow non-locality, then we must at least consider that cognitive processes may not be fully describable in local terms. Not supernaturally, not mystically, but structurally. A thought is not a point. It is a pattern, a temporally extended correlation across many neurons. Not a single signal, but coordination. Even at this level, consciousness is already relational. And if one looks deeper still, to the molecular scale, to quantum processes and biological systems, it becomes clear that life was never purely classical. Photosynthesis exploits quantum effects. Olfaction may as well. Living systems are sensitive to correlations. Non-locality, then, is not an intruder, but a property that runs from inanimate matter into life. This does not mean that we entangle thoughts, but it does mean that the reality in which thinking arises is not fragmented. This changes how we think about subjectivity. If the world is relational, then the observer is part of the network, not separate, not outside. Observing is not passive reading. It is participation, not intentional, not controlling, but unavoidable. This insight is uncomfortable because it relativizes the illusion of absolute objectivity. It does not destroy it. It situates it. Physics remains objective. Its results remain reproducible. But the framework in which measurement occurs is not fully detached from the measurer, not psychologically, structurally. And here, non-locality touches something that extends beyond physics. It forces us to rethink separation itself. Separation is not fundamental. It is an effect, an appearance, a simplification, like temperature, like pressure, like color, useful, real, but not fundamental. At the deepest level, everything is entangled, not as a formless unity, but as a network of relations. And this is exactly what experiments show. Not as interpretation, as result. When entangled systems are measured, we do not see transmission. We see coherence. States defined jointly, even when their manifestations appear separated in space. This is difficult to express in everyday language, because our language is built for separate things, not relations. But reality itself appears to be organized differently. Perhaps this is why non-locality felt paradoxical for so long. Not because it is inconsistent, but because it runs ahead of intuition. Our minds are local, our experience is local, but reality is not. And here, a new form of humility emerges. Not religious, not metaphysical, scientific. The recognition that our intuitive categories are not final. That space and time, object, cause, observer are tools, not truths. Tools that work extremely well as long as we do not turn them into absolutes. Quantum physics does not tell us that everything is arbitrary. It tells us that everything is connected. And connection is precise, mathematical, testable. Perhaps this is its greatest challenge. Not the loss of causality, but the loss of isolation. Breathe slowly. Do not judge this thought. Let it be. The world is not a puzzle of isolated pieces. It is a fabric, and we are a thread within it. As this understanding deepens, our idea of causality begins to change as well. Not collapse, not disappear, but soften. In the classical world, causality is clear. Something happens. Then something else follows. Time orders events. Space separates them. This framework is deeply intuitive. It matches daily experience. It feels undeniable. Yet within a non-local reality, this structure becomes more flexible. In entangled systems, there is no absolute first, no privileged temporal order. The outcome is defined globally, not produced locally. This does not mean that everything happens at once, and it does not mean that the future reaches back into the past. It means something more subtle. Causality is not always localizable. Sometimes it is distributed. Sometimes it is relational. Sometimes it exists only at the level of the whole system. This is difficult to accept because our everyday reasoning depends on local causes. We see an action, we see a consequence, and we link the two. But quantum experiments reveal that this linkage is not fundamental, but effective. It works. It is reliable. But it is not the deepest layer of reality. At the most fundamental level, there are no isolated causes. There are states that become actual together. The event is not a point. It is a relationship. This perspective also reshapes how we think about time. Time no longer appears as a river carrying everything forward, but as an ordering principle that organizes change, an order that arises from relations. In such a reality, the past is not simply gone, and the future is not an empty space waiting to be filled. Both are perspectives on a process that cannot be reduced to a single linear sequence. This helps explain why many quantum equations are time-symmetric, why they do not privilege a direction, why the deepest level of physics appears timeless. Time emerges when many degrees of freedom interact, when systems become complex, when information is lost to the environment. Then an arrow appears, then direction arises. But at the level of entanglement, there is no arrow. This is not speculation. It is mathematically precise and experimentally consistent. When this idea is allowed, our relationship with the future changes as well. The future is no longer an empty container. It is a structured set of possible relations that may become actual, not predetermined, not arbitrary, but constrained. And the past is not a sealed archive. It is a context that remains active, not through memory, but through correlation. This may feel unfamiliar, yet it helps explain why quantum mechanics works so well without needing to feel intuitive. It does not describe what we expect. It describes what is, and what is more deeply connected than everyday thinking allows. This understanding also changes how we think about stability. In a local world, stability feels obvious. Objects exist, properties are fixed, change requires energy. In a relational world, stability arises from coherence, from repetition, from sustained relationships. An atom is stable not because it is isolated, but because its states remain coherent. A molecule exists because its parts stay correlated. A system persists as long as its relationships do not dissolve. This is a different image of existence, not as static being, but as continuity of relation. And this image aligns remarkably well with what quantum physics shows us. Existence is not a state. It is a process that maintains itself, and stability is not possession, but balance. The longer one reflects on this, the clearer it becomes that non-locality is not an exception. It is the norm. Local reality is the approximation that emerges when many relations are averaged and details are ignored. Just as a gas appears as pressure when we do not track individual molecules, the world is not local, but it appears local because we live at a scale where averages dominate. This is not a contradiction. It is an explanation. And perhaps this is the key to making peace with this idea. Non-locality takes nothing away. It does not remove order. It does not destroy reliability. It shows us that order lies deeper than we once believed, that connection precedes separation, that relationship is more fundamental than location. Breathe slowly. Allow cause and effect to soften, not disappear. They remain valid, but they are not alone. Reality is broader than any single perspective, and we are only beginning to perceive it. If this line of reasoning is followed carefully, another question appears almost quietly, not loudly, not provocatively, but steadily. If reality is not local, How does the feeling of separation arise at all? Because our experience is unmistakable. We experience ourselves as individuals, separated from space, separated from others, separated from the world. That feeling is real. But is it fundamental? Quantum physics suggests that separation is not a primary condition, but a result, an effect that emerges when complex systems reach a certain kind of stability. This stability has a name: decoherence. Decoherence occurs when delicate correlations weaken, not suddenly, not completely, but gradually. A quantum state that interacts with its environment loses its subtle entanglements. It becomes robust, predictable, classical. Not because the quantum world disappears, but because it is covered by layers of interaction. This explains why we do not see superpositions, why tables appear solid, why objects have definite positions. Not because reality is classical, but because our perspective is. The environment is constantly measuring, not consciously, not intentionally, but relentlessly. Every molecule, every collision, every interaction acts like a measurement. And every measurement simplifies relationships. This is how locality emerges, not as a foundation, but as a consequence. The world appears local to us because we are part of systems that stabilize their internal correlations and suppress external ones. The human brain is such a system, highly coherent inwardly, strongly decoupled outwardly. This decoupling produces identity. A sense of self arises when internal relations dominate and external relations fade into the background. This is not mystical. It is not metaphysical. It is physical. This does not mean that the self is an illusion. It means that it is an emergent phenomenon, like temperature, like pressure, like color, real, experiential, but not fundamental. In a non-local reality, the self is not an isolated point, but a stable vortex in the flow of relations, persistent because it maintains itself. Not separate, but focused. This helps explain why connection is not always felt, why non-locality does not dominate daily experience. Decoherence protects us. It filters. It simplifies. Without it, reality would be overwhelming, unstable, impossible to navigate. But under carefully controlled conditions, in precise experiments, this filter can be briefly lifted. And then, what lies beneath becomes visible. Not chaos, not magic, but order at a deeper level. An order that is relational, not point-like, not local, quiet, unobtrusive, yet consistent. And precisely because of this, it is convincing. The world functions because it is connected, not despite it. Classical reality is not false. It is an approximation, a very good one. But it is not the whole. When this is accepted, the way we think about existence itself begins to change. To exist no longer means to be separate, but to be stably embedded within a network. Not independent, but coherent. Perhaps this is why quantum physics becomes calm once we stop setting it against everyday experience. It does not contradict experience. It explains why experience appears the way it does. Breathe slowly. Do not try to eliminate the feeling of separation. Understand it. It is real. But it is not the foundation. Beneath it, there is something larger. A network. A relationship. A quiet unity that appears locally, but exists globally. And perhaps it is this understanding that allows us to see the world not as a collection of things, but as an ongoing relationship in which we live, act, and understand. When all of these ideas are allowed to settle together, a picture emerges that is unexpectedly calm. Not chaotic, not threatening, but clear. A non-local reality is not disorder. It is order at a deeper level. an order not made of fixed objects, but of stable relationships, of patterns that persist because they are coherent. In such a world, meaning is not an added layer. It is not something humans project onto the universe. Meaning arises wherever relationships endure, where processes continue, where patterns repeat. A star has meaning because its internal processes remain in balance. An atom has meaning because its states stay coherent. A living organism has meaning because its relationships sustain themselves. Meaning is not a goal. It is a consequence of stability. And stability is not possession. It is an ongoing process. Seeing reality this way changes how we relate to the idea of control. There is no central point from which everything is directed. No hidden command center. There is only interaction, feedback, continuous adjustment. The universe is not a finished plan. It is a process that maintains its own coherence. This perspective takes nothing away from us. It does not remove freedom. It does not erase responsibility. Quite the opposite. If reality is relational, then every action matters, because it alters relationships. Not globally, not cosmically, but locally and concretely. A small change can stabilize a pattern or weaken it, not because it is powerful, but because it is part of a network. This is a quiet form of responsibility, not moral, structural. We do not act in empty space. We act within a web, and that web responds, not with judgment, not with intention, but with consequence. Perhaps this is the point where physics and life touch without becoming confused. Physics describes how relationships arise and persist. Life experiences what it feels like to be part of those relationships. There is no contradiction here, only continuity. In a non-local reality, closeness is not spatial. It is relational. One can be far apart and deeply connected. One can be near and still remain separate. Closeness emerges where interaction occurs, where attention is present, where correlation grows. This applies to particles, to systems, to living beings. And perhaps it helps explain why certain ideas, insights, or discoveries emerge simultaneously in different places. Not because they are transmitted, but because the context is ready. A pattern forms, and multiple systems respond. Not synchronized, but coherent. This is not mysticism. It is a well-known phenomenon in complex systems. When conditions align, structures emerge. And these structures carry meaning without having been designed. Non-local reality shows us that separation is a perspective, not a truth. Connection does not need to be created. It is already there. We are simply learning to notice it. Breathe calmly. Do not try to hold on to these ideas. Let them flow. The world does not need to be fully explained to be understood. Sometimes it is enough to recognize its structure, not as a collection of things, but as a living fabric of relationships in which everything arises, persists, and transforms. And we with it. And so we arrive at a point where nothing more needs to be proven. Not because every question has been answered, but because a picture has quietly closed. A non-local reality does not need to be defended. It stands through its consequences. It explains why experiments yield the results they do, why correlations exceed what classical intuition allows, why separation fails as a foundation. It explains why we experience a world that feels stable, even though it rests on something deeper. And it explains why, at times, silence comes closer to truth than any equation. In such a reality, knowledge is not possession. It is participation, a slow attunement to patterns that do not belong to a single observer or a single moment. One begins to sense that reality is not made of answers, but of relationships that continue, that the universe does not wait to be understood. It is simply consistent, not because it is perfect, but because it is connected. Perhaps this is one of the calmest insights modern physics has offered, that we do not inhabit a cold, fragmented world, but a coherence that sustains itself. Not kind, not hostile, simply balanced. And within this coherence, we are not spectators, not outsiders, not visitors. We are expressions of the same fabric. Our questions, our measurements, our thoughts are part of the reality they seek to understand. This is not the end of science. It is its maturation. Because science is not about controlling everything. It is about recognizing relationships. And perhaps non-locality is precisely this. Not a mystery, but a signal. A signal that the foundation of the world is not built from things, but from connections that hold. When this thought is allowed to rest, the universe does not lose depth. It gains calm. It does not shrink. It draws nearer. Breathe slowly. Release the feeling of distance, not as a concept, but as a sensation. The world is not here or there. It is a process in which everything is related, and that process continues. Quiet, precise, uninterrupted, this journey ends here. Not with an answer, but with an understanding that does not need to be loud to be true.